Hello guys, welcome to another video from DoubtGo. Today we will discuss on machine maintenance. So what is a maintenance system? It is a methodology or a strategy for establishing a good maintenance management principles. It provides a framework for identifying, mapping and controlling elements of maintenance functions. What is a maintenance strategy? It is a long-time plan and covers all aspects of maintenance management. It sets a direction for maintenance management to achieve desired future state of maintenance. On what basis should we select our maintenance strategies? The tasks that have to be performed and on what frequency they needed to be performed. The age of the plant, the manpower that we have, the availability of the equipment. Can the equipment be replaced or it has to be repaired? The shutdown cost during the maintenance and the downtime during the maintenance. Breakdown or reactive maintenance. In this, the repair is done after the failure has occurred, but minor adjustments can be made. It is used when there are few equipments, the repairs are simple, and a sudden failure does not cause financial loss, safety issues and hazards. It cannot be used in big industries where there are a lot of equipments and each equipment is dependent on other equipments. It is also not used in chemical and processing industry because a failure of piping system can lead to release of hazardous materials in the environment. Its advantages are that it is low cost and it uses low staff. Its disadvantages are it gives an unplanned downtime and it may require help from outside. It gives an insufficient use of resources. Corrective maintenance. It is the action for correcting or restoring a failed equipment. The actions may be taken before or after the failure has occurred, as per the convenience. It is a one-time task. Once started, it is always completed. Opportunistic maintenance. As the name suggests, during maintenance of one component, the opportunity is used to change other worn-out components too, even though they haven't failed. It is used in multi-component system and for non-monitored equipments. It is economical in long runs. Routine maintenance. It is the simplest type of maintenance. Its actions are avoiding, reducing and eliminating the consequences of failure. The actions are taken at regular intervals and it needs a very little investment of time and money. For example, routine maintenance is used in trains. When a train stops at bigger stations, a group of maintenance people immediately start checking and doing minor jobs, like identifying loose parts and tightening, cleaning the moisture brakes and checking brakes. Preventive maintenance. It includes any action to prevent the equipment failure or downtime. It is a planned type of maintenance. In this type of maintenance, the equipment is restored back to nearly original condition. It is of two types. Fixed time maintenance. It has simple routines that must be followed regularly in intervals of days, weeks, fortnights, months or quarters. And condition-based monitoring. It is similar to predictive maintenance. Predictive maintenance. In this, the maintenance is done on the basis of condition of an equipment. So in this type of maintenance, we need to know the actual condition of plant or the equipment. It gives an estimates that the degradation of the equipment has occurred and it is going to fail. And so the problems are addressed as and when they are identified. It has three distinct stages. Detection of the condition of the equipment, analysis that the equipment is going to fail or not, and taking corrective measures on it. Temperature monitoring. In this we use the temperature of different parts to determine that if there is a problem or the product is going to fail. The changes in temperature can be due to wear, friction, slippage or impacts inside the equipment. The techniques used for temperature monitoring are temperature crayons and tapes. It may also be done by a simple touch for low temperatures. Optical pyrometer and thermocouples are used for high temperatures. Fusible plugs are normally used in boilers. They are a safety measure but can also indicate a malfunctioning. Infrared scanners and resistance temperature detectors. Thermography. It uses infrared sensors. The infrared sensors measures the energy of object surface and produces a detailed visual image that depicts its temperature profile. It is safe, cost-effective and non-destructive type of test. Vibration monitoring. The vibration from different parts is used to predict the failure. Vibrations is present everywhere in a mechanical system. It may be due to worn out bearings or imbalances. In this method, the frequency and amplitudes of vibration gives a measure of failure. It is fast, easy and less expensive. Vibration signature or spectrum. In this, a graph of vibration of each and every equipment is made. The plot can be of amplitudes and frequencies of the vibrating components. The changes in these signatures indicate a failure. Using lubricants to detect a failure. So there are three types of tests. First is the analysis of the fluid property. Its physical and chemical properties like viscosity, pH and additive changes. The contamination analysis, the amount of dirt, glycol, soot, water and fuel present in the fluid. And the wear debris analysis. In wear debris analysis, the sources of wear are identified first. And then the type of debris, like the amount, size, shape, composition. Numerical methods monitoring uses spectroscopic oil analysis. Direct reader ferrography is used only for ferrous materials. The filtered debris analysis or separation by a filter can also be used to detect wears in a lubricant. Scanning electron microscope and some engine oil test kits and other oil test kits are also available. Lab tests for oil quality, wear and contamination can also be done. So types of contaminants. The first type is rubbing wear particles. It is due to normal wear and small flakes of metal are formed. The fatigue chunks are formed due to surface stressing in gears or shafts. Large chunks of metals are formed. Sliding wear particles are due to metal contact with no lubricant film, like in gear teeth and in loose bearings. Cutting wear is an abrasive type of contact. The contact may be between metal or the contact may be between metal contamination metal. The chunks that are formed are in form of curls. Laminar wear is due to stresses in rolling elements like bearings, and thin flat flakes of metal are formed, and the presence of oxides and rust due to aging. The sources of contamination. Built-in contamination. It includes manufacturing debris, permanent debris, and other damages. Internally generated contamination is from the long runs and wear from gears, bearing and corrosion and pitting. Ingressed contamination. It includes moistures, acids and different kinds of fumes and gases from atmosphere. Improper maintenance, cleaning and protection also add to the contamination. The contaminations may occur due to accidents or some malicious acts. Biological contamination is due to bacteria, microbes, algae, fungi and other microorganisms that may have developed in the fluid. Ultrasonic monitoring uses ultrasounds to detect a failure. Ultrasounds are high frequency sound waves. They usually start at 20 kHz and go up to MHz range. These are directional testings. They are used for leak detection in pressurized or vacuum systems. When a gas escapes from high pressure to low pressure side through a small hole, a noise is created. and that can be identified. Mechanical failure. Ultrasonic noises are created by friction between two objects. Lubrication improvement. If the equipment is under lubricated, it will lead to metal contact and wear. And if the equipment is over lubricated, it will lead to heating up of the bearings, and the bearings seals may possibly pop out. Valve inspection. In this, the valves are inspected and the sound's intensity level both upstream and downstream of the valve is checked to detect the failure. Crack detection. In this, the sound energy is introduced into the product and it travels and propagates through the material. If there is a discontinuity, it is seen in the output of the wave path. It is also used in electrical inspections for detecting formation of arcs, corona, or insulation breakdowns. It can also be used for detecting thickness of materials. Radiographic monitoring. In this type of monitoring, a radiation is passed through the material and a radiographic image is produced. The cracks or holes in the materials attenuates the radiation. The radiations that can be used may depend upon the safety considerations like X-rays, neutrons, or even gamma rays. Thank you for watching the video, and if you have any queries, please comment on the comment section below. If you liked the video, please like, share and comment on the video. And subscribe to our channel. Thank you.